So indeed, I will focus on a much more, let's say, industrial application talk, starting first by having a very short introduction about Faurecia, and then having a more dedicated focus on acoustic and soft trim, where porous media is mainly involved within Faurecia. And we will have, during that second part, let's say, a generic overview of the processes, as explained by François-Xavier. Then I will try to showcase a bit the porous media expertise we are using, which is indeed a repetition compared to the previous talk, for sure. And then we will discuss about the new trends in the automotive business and where do we have synergies with porous media. So let's start very, very quickly by Faurecia. So we are in the top 10 of the automotive suppliers worldwide, today leading almost 18 billion euro sales, yearly sales. And we are leading 3 main activities: seatings, interiors, and clean mobility, which was previously exhaust division oriented company. Just a key, yes, maybe a key message is we are in 1/3 of the equipped vehicle worldwide, which is not nothing. We are basically a European-based company. Our headquarters is in Nanterre, Paris. So almost an half of our business remain located in Europe. Asia being growing a lot, and we will have in the coming months Asia coming, and especially China becoming our second region before North America. In terms of sales by customer, we are owned by PSA at 40%. Nevertheless, our first customer is Volkswagen and then Ford prior to PSA Group. But again, we are in one car out of 3 on the global market, so we are almost everywhere. 3 main divisions today, and I need to take care about the time, but I will develop that later on the tomorrow. But so today, 3 main divisions. First one is about clean mobility. Clean mobility. Okay, I can do like that. Yes. So clean mobility being previous exhaust division. So we do have some porous media activities there with of course high temperature and flow management, but the main activity is not there. Nevertheless, we are worldwide number 1. For seating, we are worldwide number 1 as well for complete seats and structures. Huge block of foam. You just have to know that 50% of the overall absorption in a car, 50% is driven by the seat. So the reverberation time in the car is basically driven by the seat, at least for textile seat. And finally, interior. So I'm part of interior, where we are producing central console, IP, instrument panel, door panel, and acoustic modules. And we are again number 1 or 2 in the world on that domain. So let me focus, after this very generic group presentation, let me focus on acoustic and soft trim division, where porous media expertise is. So we are even more European company, almost nothing in that domain in North America, but based in Asia and Europe. And the products we are delivering are the products you can see there. So we are speaking about carpets, dash insulators. So dash insulator, sorry, being the part beside the instrument panel, the one you can't see in the car. Outer wheel arch liners, so the part to cover the wheels. Package tray and all the trunk trims, and finally panel trim, the headliner in the car. So basically we are able to deliver all the soft trim in the car in that domain. Maybe just one word on that. This market is driven by the material. The price, or let's say the cost of those products, is 70% driven by the material. So if you don't master the material, you kill your business. So mastering the material is the key for this kind of business. This is the reason why we are not only providing downstream processes, so parts to our suppliers, to our consumers, but we are vertically integrated in a large number of material in order to master the full chain, upstream and downstream. So managing the material, again, this is the key. Believe me, when your market is driven at 70% by the material, you have to master everything. That means we are basically able to produce by ourselves, except polyurethane foams, chemicals, we are producing all the material we are using. So I will just focus quickly on that. First with carpet. So for most of the people, a carpet is a carpet. We are using carpets as airflow resistive screen. So we discussed a lot during this morning, and I just have a quick look on the presentation for yesterday. Sorry, I was not able to attend. Indeed, we are using a lot airflow resistive screen, and carpet being the first one. We have several aspects in the carpets. What I want to focus during the few process slides I will showcase now is this process is a very long process, and in order to manage the final airflow resistivity, we have to manage each step of the process, and this is where the knowledge is basically. So let's start by the quality. So we do have several quality in the carpet. First, what we call flat needle punch, so very without any design aspect. Then we have what we call deluxe carpets, so in which we pull fibers out of the initial flat needle punch. And finally, we have tuft version that are much more rich aspect. Don't focus on that. Just remind that tuft is basically product driven by a yarn with polyamide materials. So we are using yarn, infinite yarn. When needle punch carpets are driven by fibers, let's say 60 to 80 millimeters long fibers, very thin fibers. We are speaking about 10 decitex fibers, which mean 10 grams for 10 kilograms of fiber. And this is this kind of system that we are using, of product that we are using. So let me focus a bit on the process, as I told you, because again, in order to manage this layer, this kind of layer, which is a stupid carpet at the end, but the final quality of the car is driven by the fact we are using this layer as the airflow resistivity layer. As I told you, the process is a very long process, but for all the quality, needle punch, random velour, we are basically using the same line at the beginning. So we are using fibers that we have to melt in order to maintain. So again, we are speaking about 60 to 80 millimeter long fibers that we are melting to manage and to guarantee to ensure a proper color. Then we have fiber opening. Then we have carding process in order to create parallelized web. Then we have napping process. So we are stacking webs in order to guarantee the final surfacic weight of the product. And then we have a structuration layer with needle punch machine. So I will develop that just a bit. We may have a video starting soon. So this is the first step about carding and cross-lapping. So this is the kind of web we are using. And then having a cross-lapper to create a mat, this kind of map, to maintain the final quality of the product. So it's a bit short, a bit quick video, but this is the very first step. So using those 60 millimeter long fibers, we are creating a web that we are finally lapping in order to create that process. Finally, we have, then we have the needling process. So we are using typical needles. So you will see again a bit of process. So we are using board of needles. Board of needles, you can see there a board of needle. A needle board is typically 6,000 needles on a 2.5 meter long board. And we are impacting the carpet up to, let's say, depending on the quality, but up to 600 needle shot per centimeter square, okay? And this is definitely driven the tortuosity of the product, because of course we are merging the fibers, and this is a key parameter for the tortuosity and finally the airflow resistivity, the final resistivity of the product. As you may observe, the needles have, let's say, hooks like that, one there, and the kind of needles we are using is of course adjusted to the fibers in order to be able to master the tortuosity, as you may observe on this picture. So this is one of the key parameters. We have to check that on a regular basis because, of course, the longer and the older is the needle, the smaller is this shape, and then we may miss some mechanical bonding. So this is the end for needle punch carpet. So then we may have an additional process which is called a dilure process. So this is a short video with the dilure process. So again, needles, but needles are a bit different because instead of crossing the carpet with classical needles, maybe you can see this needle. This needle is in fact a fork, and with those kind of needles, we are pushing the fibers, as you can observe there. We are pushing the fibers to create this shape, which will be, let's say, a velour aspect, because we are pulling out of the basic carpet, we are pulling out the fibers to enrich the quality. So this is what we call dilure aspect. This will have a direct impact on the absorption. So nothing about the tortuosity or airflow resistivity, but basically about the thickness. It's a direct driver with the thickness, because we are pulling out some fibers. Finally, we may have a cutting process, because if we are pulling some fibers, it creates some loops. Then we can cut the loops to enrich again the quality of the carpet. So this will have, again, a positive impact on the final absorption capacity of the product. Nothing about the airflow resistivity, but this will enrich the overall absorption, mainly, again, about the gain in terms of thickness. So the main goal of those slides is just to highlight the complexity of the process. If we don't master, and this is the fiber mat process, but of course we have to master first the fiber selection, because if you don't select properly the fibers, then the final quality will not be good as well. So all the steps are key to master the final quality. And this is not the end, because then we have to adapt what I call finishing process. So it's about having some induction or coating. This first induction was a latex induction. Then we have a drying with a oven. We may have laminating process with PE or extrusion processes, and all this will impact the final quality of the product in terms of airflow resistivity, in terms of Young modulus as well. The latex penetration, for example, is a key driver for mastering the airflow resistivity. The latex is used to avoid and to guarantee a good abrasion on the carpet. But depending on the latex penetration ratio, you are able to tune the airflow resistivity as well. Just final video, I guess, which is scattering. So we were discussing about PE powders during the lunch, and we are. And this is the overall activity on that. Okay, no, not last one is about induction with non-woven backing. Okay, so this is, again, just to focus on, and this is a summary, on all the steps to be able to create a semi-finished product. This is definitely a semi-finished product, which will be, sorry to insist, 70% of the overall cost of our product. And if we do not master this 8-step process, then the quality cannot be reached. This was for aspect carpet. We do have the same approach for what I call semi-structural product. So we are speaking there about semi-structural because the product is a structural product, but without any crash specification on that. So it's not part relative to safety. For example, the one we are using in a double floor for those who are driving SUV or for parts such as package tray. So we are using basically maybe I made that. The carpet's main material is about PET fibers. There we are speaking about PP fibers reinforced by glass fibers. But the process is basically the same. We are using fiber weighting, ball opening, mixing, which is a key process to master properly the quality. The web forming with carding machine. The web superposition with cross lappers, and finally the bonding with the needling. So this is basically the same process. And again, all the steps are key driver for the absorption property. 100% of the package tray are key contributors to the overall absorption coefficient in the cabin. This is maybe not key, but this is one of the parts which is contributive to the overall absorption in the cabin. Then we have a large scope of, let's say, felt process. I will not develop too much. That one is a well-known airlay process. So we are using, to make a long story short, air flow in a machine in order to blow fibers and to verticalize fibers, or at least to give a proper orientation on fibers to manage final felt. I guess Luc presented yesterday all the models, and one of the first model was about parallel pores. I'm sure you presented that. So basically, in order to manage properly parallel pores, such a Mickey model, we can use an airlay process, which will be completely in line with such kind of model. So the process, my message is definitely that one. The process and mastering the process is absolutely the key to guarantee the final product. And then we have, of course, needle punch again with needle boards or a thermobonding oven for the consolidation. Again, sorry, it was said many times during the 2 days, we are not delivering a single layer product, but each time multi-layer product, the basic principle being, of course, mass spring system. So we are vertically integrated as well for heavy layer, let's say, septum construction. So I will not develop that. We are not in a porous media there. But of course, we are vertically integrated as well for porous media. Heavy layers. We are, so still, and last slide about upstream will be a PU process. There is much more confidentiality on that. So I will be less explicit. So of course, basic of PU is about having polyol and isocyanate mixing. We are mastering completely this approach, knowing that we are buying, let's say, classical component, polyol and isocyanate, plus additives, of course. And then we are mastering the full chain of the product. The way we will use that, and I will develop later on, is, of course, a very good way to master the micro parameters. And Fabien presented that yesterday as well. So the micro-macro approach is part of that, and is much more easy to master with the PU process. We are basically using a closed mold processes. Very short comment about downstream. Basically, it's easy. We are mastering properly the mat, and then we destroy everything with the process. nevertheless, we have to guarantee the final product. So of course, it's a bit more complicated. Basic process in the automotive industry is about classical approach. So we are warming up the material with many different kind of oven. It could be a hot plate, it could be infrared oven, it could be about hot air. And then we have a molding unit, could be cold unit or warm unit. And then we obtain a final model carpet. So this is hot mold units for the carpet. This will be a cold for the package tray, for example, but basically the process is the same. And this is the final part we will deliver. So we are mixing and merging, for example, the aspect surface made of PET plus the carrier made of PP glass fiber. And then we are compressing all the product in order to maintain and to guarantee the final quality of the product. Of course, in terms of stiffness, in the case of this package tray, but as well in terms of absorption performances minimum. For the heavy layer forming and foaming, again, we do have full processes on that. So I will not develop, but of course we are able to fully master that. Maybe just one comment on my side, because I will develop that later on. Take care about the 3D orientation of the part. So this is a carpet backing, okay, flip like that. As you can see, this is definitely highly 3D product. Luckily, Pierre, in a few minutes, you will focus on much more flat panel, but that one is really a 3D approach, and we will have a modelization issue on that. So this was for a short introduction about the processes. I guess you catch well, hopefully, the way we are producing, and let me now develop a bit more the porous media expertise we have to deliver to our customers. Depending on the OEMs we are dealing with, we may have to address either a full car target or very refined material definition. So we are able to address all the steps of the process from the full vehicle to, of course, to the laboratory. So let's start by the full vehicle. So in the automotive business, of course, we are dealing with cars. So we do have several acoustic chambers, and we are able to test a full car. So this is about semi-conic chamber. So very classical, of course, dedicated to automotive. So we have four-wheel chassis dyno in order to test our product in the overall configuration. Then if we go one step before, we will go to the module level. So we have to characterize the module level. What I call module level is basically you take a car, you cut the car, and then you will focus on the performance of the cutted floor or the cutted cockpit. Okay, so we are equipped to characterize. As you can see, this is a cutted cockpit, and this is a cutted floor, and then we are able to estimate the transmission loss, for example, of the elements in those chambers. So this is the module activity. And finally, we have to master the material again and again. This is 70% of our cost. So we have, I would say, state-of-the-art characterization for the material. This is true for, let's say, what I call macro acoustic parameters. So we are using, well-known in the automotive business, absorption impedance tube, of course, as well as small cabin. So this one is a typical automotive-oriented insulation test room with 2 cavities, as you can see there. So we are using a flat sample for insulation. The alpha cabin, which is again a typical automotive oriented application for diffuse absorption coefficient measurement. We are using, and you've got a presentation from Nourdine yesterday, Mecanum and Matelys application for period parameters characterization. So this is true for the 3 microphone tube, for example, but this is true as well for the porosimeter. So we are 100% of the material we are dealing with are characterized by yourself. So we are mastering the full chain on that. For the airflow resistivity, we develop our own airflow resistivity device, hopefully in the norm to be checked. And then we have all kind of Young modulus devices, even complex Young modulus capabilities. So again, all the material we are delivering to the customer are characterized. This is definitely the unique way to master this chain. So years ago, we do have an issue with Toyota. It was years ago, I can say now. It was Toyota, and the issue we have with Toyota at that time was about the needle quality, and we discovered, thanks to biode characterization, that the needling quality was not good enough to ensure the final quality of the product. So again, mastering that is the key to be able to estimate the parameters. So what are we doing on a daily basis? Well, I will not develop that because it was the purpose of the 2 days event. So we are able to tune all the parameters, and mastering those parameters enable us to tune, for example, for absorption, all the parameters we have to deal with. Working with, of course, thickness, but airflow resistivity, porosity, or as well tortuosity. This expertise is today completely, the OEM do not have this expertise anymore. So this is not only by Faurecia, obviously, but the suppliers master that, but the OEM are not able to do that currently. Then we have a full test equipment, but I will not develop, so we are able to, this acoustic tech center is definitely it's a fabulous tool. We are able to play with any kind of system, laser vibrometer, any kind of acoustic measurements, vibrometer, accelerometers, whatever. We have plenty of microflown PU probes. I don't know if you use that, but we are able to manage pressure intensity measurements in real time thanks to a large number of PU probes. Okay, so this is where we are. Again, I like this slide. My daily job is definitely to be able to manage the material definition in order to follow my customers that are defining the customer needs basically through benchmark activity. And then, depending on the level of maturity of the OEM, and we are living currently in a very interesting period where we have more and more newcomers. We were discussing about BYD during the lunch. Those newcomers are very young in the way they are working, and we may have targets today expressed just in a vehicle. So the customer ring the bell and let's say, okay, please deliver a car which will be at that level. Of course, depending on the level of maturity, we may receive some, and then we have to deliver. We may receive some targets that are expressed in terms of global vehicle, as well module targets. So, for example, a dash inner with or without IP, instrument panel, sorry. It could be only about component targets, or it could be about material. Let's say, just as an example, Toyota will be around there. So when Ford will be around there. So depending on the level of maturity of the OEM, we may have to deal with several approaches. And of course, we have to manage the full validation by ourselves. So this is why, again, we have a full state-of-the-art laboratory in order to characterize the material. Then we have the couple rooms to deliver the module validation with or without IP, for example, and finally the full vehicle with the chassis dyno I just presented to you, as well as any kind of psychoacoustic parameters, but I will not develop that today. A few words about product. We are delivering multi-layered product. When I started my career in Faurecia, in 2001, the life was much more simple. We were delivering 90% of mass spring system. There is no more mass spring system in the automotive business. We are delivering multi-layer system with multi-thicknesses. So those wording are typically Faurecia words, but you will find that on the market with competition. All the products are mainly multi-layer products. So this is a key for the final process, because I will develop that again later on. We have to master all the layers by themselves. So those layers are basically for insulation, and then we have product much more dedicated to absorption. So let me just focus on that slide. I like that one because this is basically our daily basis. Those description, this line is about all the material we are able to deliver. The characterization is done in perfect words with flat sample, and we know the performance of the parts at flat sample level. The parts, as I told you previously, are highly 3D oriented parts. So finally, we have two ways of working. Either we use TMM approach. Nourdine presented that yesterday for sure. So either we use TMM approaches, eventually what I call 2.5D TMM, so using multi-thicknesses TMM. So we take a part, we slice the part in let's say a slice of thicknesses, 5-10 millimeters, and then depending on the range of thicknesses, we are applying TMM model, and then we compute the overall performance on the TMM sense. It's very efficient approach, having let's say a performance evaluation of this with TMM, what I call FTMM 2.5D, is very efficient. We are speaking about, I don't know, 20 minutes for the full chain meshing including. And of course, and it was presented this morning, we are also equipped to manage full 3D simulation when, let's say, depending on the meshing effort, we need from 24 to hours to sometimes a full week to be able to manage that. So again, depending on the level of maturity, we have to cover everything. The key message on that slide is definitely again and again, we have to master the material. If you just ask for a unique biot characterization set of parameters for a unique thickness, you're dead. This is representative of about absolutely nothing on the car, because again we are speaking about 3D parts like that. So we have to master all the thicknesses of all the materials, which is a huge quantity of material in database. So material is the key. Let me start by the basic of material. And we work a lot. Let me notice the activity and the work of Camille Perrault, of course, the one of Fabien Chevillotte. We are working a lot on what we call micro-macro approach. Micro-macro approach is very simple. This is the unique way to speak between a chemical engineer and NVH engineer. Those people are completely two opposite people, and they can't speak, except if you are able to deliver a message saying, okay, if you change the airflow resistivity, the chemical engineer is dead. But if we are saying, I take a unit cell and I need to extend the characteristical length of a cell in a PU, for example. Then the chemical engineer is able to tune the chemical recipe to manage that. So for us, industrial people, micro-macro approach means simply being able to speak between chemical engineers and NVH engineers. Let's have a look on as I told you at the beginning of my career, I was just speaking about mass spring system, and now we are speaking more and more about multi-layer systems. So this is a classical foam heavy layer system, and this is equivalent, hopefully, a 3-layer system with spring layers, airtight layer, it could be about a barrier, heavy layer, whatever, and finally absorbing material, foam or felt. The goal for us will be to master that 3 layers in order to tune the parameters. This was presented hopefully by Fabien or not, I can't remember, yes. So we are using the micro-macro approach to define and the extension. So Camille is working on that as well. So Min Tan Hong in our team is leading that. The goal for us is to definitely define equivalent cell and then to estimate the macroscopic parameters using this equivalent cell. That for, and I will not develop, this is not the goal. What's happened? Sorry. So my laptop is crashing. Wait a minute. Yes. Microsoft PowerPoint is not responding. Restart. Sorry. Oops. I do like that. What's happened? Sorry. There we are. Sorry. Okay, so this was, I suppose, presented yesterday. So we are definitely using that, as I told you, to be able to communicate and to fine-tune our parameters, knowing that to estimate the macroscopic parameters, we are using the 3 asymptotic calculation, Visco-Navier-Stokes for the low frequency, inertial Laplace flow for high frequencies, and thermal conduction for low frequency as well. So thanks to that, we are able to estimate the parameters. I again maybe presented yesterday by Nourdine. We may have alternative approach such as semi-empirical model. I don't know if you presented that yesterday to go in that direction. Nevertheless, my industrial approach is more that one. So you will find 2 different porosities there. So we are able to test different performances depending on all the porosities we are able to deal with. And thanks to that, so you will have, in that case, 0.9 and 0.95 porosity presentation there. And this is for the decoupling foam. So we are speaking there about a mass spring system. And thanks to those kind of simulation, we are able to select a zone where the performance will be the best. So it was and it is a key element for us to determine the area where we have to work to optimize in terms of porosities in that case, the final performance of the product. So this is used on a daily basis. As I told you, we are using this micro-macro approach. So this the semi-empirical model is giving the same kind of result, and this is the way we are using we are developing on a daily basis our foams for both insulation and absorption to define the key parameters. Okay, so again, this tool is for us a key tool to be able to speak between mechanical engineers and chemical engineers. This was about material level. Let me move one step further. Now we have to move to module approach. This is the kind of tool we are using for simulation. So it was more or less presented this morning. So we do have BEM-FEM approaches for the low frequencies. We have SCA and virtual SCA for the high frequencies, and we are using ray tracing method and virtual SCA for the mid frequencies. The goal for us is to be able to characterize the module. So we move from the material to the module. This is the way we are using that. So either for a complete carpet simulation, complete dash inner, seat, structural and equipped seat, headliner, of course module. So module being sorry, you missed my cockpit being dash insulator plus instrument panel, and finally full trim vehicles. So why do we use basically BEM-FEM approach? It was highlighted a bit this morning. The main reason is about the let's say performance of the tool. The FTMM approach is very interesting to obtain a very quick ranking on the product. So as I told you, we take a part, we slice a part in thicknesses, in slice of thicknesses, and for each thickness we compute TMM results, and then we compute a global performance. This is very efficient. We can compute a full core in less than 10 minutes for each module. But the final, if we compare that with the measurement, so in green you have a look on the TMM approach, and in blue we have the module measurement in a capillary aberrant room. So as you can see, the trend, the slope, because of the curvature of the system, so we are not speaking about infinite panel and we are not speaking about flat panels. So this simulation is very interesting to be able to rank the product, but it's not useful at all to characterize properly the full vehicle performance. This is why we are using more and more FTMM approach. What does that mean for us? Again, I was saying a few minutes ago that if you just manage a unique characterization, you do nothing. So this is an example. So we have a publication with Audi on that. This is an example of a typical dash inner. So this part is, I need to present the part a bit. So we have a mass spring system on the border, I call that the crown. On the border of the part, you will have the effect there. And then in the middle, we have a heavy layer, which is that, no, sorry, where is the heavy layer? I don't know, this one is the interpenetration laser. So let's say barrier, absorbing equivalent septum barrier. And that one is the foam part we have on the under the barrier in the central area. And finally, we have absorbing cotton felt on the top. So this part is completely three-dimensional part. All the area of the part are driven by a multi-layer system, and no one is a unique thickness in that domain. This is why for each material, you will have several colors. One color means one thickness, means one biot characterization. So for this simulation, for the peripheral foam, for the mid part foam, and finally for the absorbing cotton felt, we have, I don't know, maybe 50 or 60 buyout parameter characterization. So again, this is why this is a key. Pourquoi ça fait ça, putain? Sorry, again, crash. What's happened? Ah, no. Restart again. Yeah. Sorry, Microsoft issues. Okay, so this is finally the. So remember, we start from this FTMM simulation, which is again a 10-minute simulation running time. We apply our systematic characterization approach, and finally we are able to reach such kind of correlation where still in blue we have the measurements, and in green we have the simulation of the complete part, having a much more let's say proper correlation. Not only at 1 kilohertz as it was the case with the FTMM approach. So my message is not to say that FTMM is not a good approach at all. Again, for the ranking, it's a key performance, but you cannot estimate the full car performance with such kind of model. Then what we are doing is to extend that to the module. So after the dash inner, so you will find again the full part at this location, but on the top we are adding the air cavity, the duct, and the IP by itself in order to create a full module. In order to create a full module, so the dash, the air cavity behind the IP, the duct cavity, all the duct by themselves, and finally the IP to create a module, and finally to compute the final performance of the module. So it was the correlation with. Ah putain. Bon, alors là c'est infernal. Ah, okay. So it was the correlation with without IP, and finally now with IP, with a very good level of correlation as well. Much more important than the level of correlation is the insertion loss impact or the transmission loss impact, and of course the ranking between the performance is there. So this is very useful for characterization. Let me have a look on the issues we have on the daily basis. As I told you, our parts are definitely 3D oriented parts. The computation time, a typical computation time for such kind of element is 1 night. The typical meshing time is 1 week. So we are completely blocked by the meshing time. So we are developing our own tools to be able to manage automatically the meshing of any kind of 3D parts, which is one key element. The goal being to start, and this is to me a unique link between a TMM approach and a FEM approach. So the goal being to start with a unique meshing of a single layer of a dash, for example. And yes, maybe I missed that because in the drawing we are managing the layers. So remember the previous slide about a 3-layer system: foam, interpenetration layer, and absorbing layers. Those 3 layers are not represented at all in the CAD data we receive. So the dash is just given as a unique part, and nobody cares about the layers in between. So we have to consider a reference surface, a reference element of one of those layers, and finally having a virtual extrusion process. We have to be able to estimate, depending on the final thickness of the part, we have to be able to estimate the overall thickness of the material in order to automatically create the meshing. So this is what we are doing, and we are as well working with FFT on that approach. So we start from a CAD data. We take the slice of thicknesses. We define a mesh, and then we extrude that process. So maybe this one will be no. This one is great. So we define reference mesh, then we extrude that mesh automatically in order to create the final used mesh. It's a bit small, but again, in blue you have the measurements, and in green you have the manual meshing, that one. And the red one, so basically no major differences. You have the 2 hours meshing, automatic meshing, compared to 2.5 days for that one. So which is again key parameters. This is to be applied not only for a simple part, dual layer or 3 layers part, but back to my previous example of the OD case. Remember with the crown, which is a mass spring system, and then in the middle we have the foam interpenetration layer and absorbing cotton felt. So then for each, I call that a meta model. So for each zone of the part, we have to slice the part in slice of thicknesses. For each thicknesses and for each material, we are characterizing the biot characterization, the biot parameters. And for each of them, we are applying the automatic meshing, the automatic extrusion, in order to create a 3D mesh, having a proper management on that. So this is something we have to finalize, and again, it will be a key element for the final performance. I will just have a few words about virtual SEA and SEA components. So you presented that this morning a bit. This is so as you may observe on the let's say this slide, for example, we are able to today, depending on the computation capability we have, but we are able to reach up to 2.5 kilohertz in one night. We of course have to manage the overall spectrum. So in order to extend the computation capability, we are more and more coupling SEA approaches, statistical energy analysis approaches, with BEM-FEM approaches. The goal for us is to, so we call that virtual SEA. Our partner Interact, Gérard Borrello, is working a lot on that. So the goal for us is to use body in white FEM model, and then using genetic algorithm for let's say FRF in that body in white model, we are able to define substructure, or substructure, for each substructure we will then define a simple SEA model. Okay, so using initial FEM model, we are able to define for each of them a simplified SEA model. And finally, the dash will be simulated using very simple academic elements. For each element, nevertheless, we are applying for each subsystem, we are applying the real 3D mesh of the part. And again, we are applying the real biot parameters for each slice of thicknesses for each material in the domain, which is the key for this material database. So this is, to me, a very interesting process to extend the capability in terms of simulation. And that slide, you are able to observe a bit small, but the different quality. And again, something very interesting for us, because we are able to extend the simulation up to 10 kilohertz, let's say, without any additional simulation effort, thanks to this kind of approaches. Synthesis model. I'm going too fast. Synthesis model. Finally, we have to deliver full cars, full vehicle. And this is the kind of synthesis model we are delivering. So for full vehicle characterization, we develop our own methodology, having a first step, which is material, let's say, sound qualification, vehicle sound qualification test. So we take a car, and for each subsystem in the car, for each zone in the car, using typically a microflown PU probes, we are measuring the radiated intensity in the car. So thanks to that, we are able to create such kind of 3D maps that are representative of the energy which is coming in the car. And thanks to that as well, we are able to create ranking of the main contributive elements or the main noisy panels in the car. This is very interesting, but finally, we are not really sensitive as end users to those kind of systems. Why? Because, of course, I cannot detail that, but if, for example, the main noisy element, when I say noisy, I'm speaking about the radiated intensity. If the main noisy element is in the trunk, and if I am driving the car in the front, maybe I do not listen to that panel because of many insulation, absorption, or whatever effect in the cabin. So this ranking is interesting, but we have to combine this ranking with a second step of process, which is basically the frequency response function in the cabin. So we are measuring the frequency response function between all the surfaces in the cabin and the passengers in order to create a second information. So we are able to measure that frequency response function, but we can also, you were presenting this morning the ray tracing approach. So we are able to use ray tracing to characterize those kind of parameters as well. So finally, if we have this ranking and the frequency response function, if I combine those two information, I'm able to create a second cartography, which is not only a cartography of noisiest panel in the car, but this cartography is a real cartography of contributive panel in the car. So a red panel means a panel that, as a driver or as a rear passenger, is really contributive to my comfort. Okay, so instead of working on this ranking, we will work on this ranking, which is a contributive ranking, which is much more interesting for us. And then we will, based on that, we are able to deploy all the methodology I just presented to you in order to define the material and the system on this contributive panel ranking to propose a new package on a car that will match, that will fit to the OEM expectation, modifying, for example, the carpet absorption using a new process or using a new complex definition on the car. So this is what we call synthesis model, and this is a way to define package in order to reach cost and weight saving, managing everything. My Siri is asking. Playing to that. So this point is something very important for us as industrial. We are not, well, we are experts in the porous media, but we don't have to be experts in all the domain of the system, but we have to merge and to manage multiple simulation and characterization system, and those kind of methodology is for us very interesting to be able, remember my V-cycle presentation, to be able to focus and to deliver and to prove that the package we will deliver is matching and is will answer the OEM specification. I was very quick on that part, I guess. I will now have a few slides on the future, knowing that nevertheless this is the daily work today. Where is the automotive market and where do we go today? I like this slide a lot, and those are the 4 megatrends in the automotive industry today. The first trend that we are dealing with is connected material, connected cars. The car will be more and more connected, and we are all requesting for a lot of connection in the automotive business. And even if Siri is listening to me, this is something we have to again. This is the main driver today to buy a car. Believe me, if your car is not if a car is not equipped with Android Play or CarPlay or whatever, the connection is clearly a mega trend. Autonomous driving. Autonomous driving is also a mega trend, and this autonomous driving will offer us a lot of new experience in a car. And this will have, so there is very few impact on the porous media for connected, even if I will develop that later on. For autonomous driving, we have a huge impact on material on this megatrend. Why? All the presentation and all the material we are dealing with are today used for a standard utilization in a car, which is something like 5 or 8% maximum of the overall time, which means that 95% of the time, 95, yes, a car is sleeping on the parking without any drivers or any people in the car. So if tomorrow the autonomous driver and autonomous car is really increasing a lot, then we will have a major issue on all the porous media we are dealing with, especially on the decor material, the carpet especially, to offer something new on that domain. Car sharing as well. We have direct impact on the material we have to use in the car thanks to car sharing. And finally, electrification. For those who are traveling sometimes in China and especially in Shanghai or Shenzhen, believe me, the electrification is not a dream. When you are walking in the Shanghai street, I was in Shanghai last week, already, let's say 25 to 30% of the car in Shanghai are electric cars. And it's something very, very sensitive, even if you are walking in the street, you can feel that very properly. So those 4 megatrends that are, let's say, commonly shared by OEMs have been deployed for Faurecia into 2 main strategic priorities. The first one is about sustainable mobility. We call sustainable mobility all the solution for zero emission and air quality. This is for a company like us a big change. We are dealing on a daily basis with the exhaust division, if you remember my introduction slides, and we will more and more be focused on a solution for zero emission air quality, which means a lot of new material involved in the automotive domain. As an example, we are more and more dealing with composite and structural composite chassis to cover the battery pack. This is very good for light vehicles. This is a drama for NVH people. We are speaking about a very stiff material with stiffener everywhere, and which create a lot of radiating noise in a car. I can't say who, but I can tell you that we have European OEMs that, let's say 2 years ago, tried to manage a full composite mainstream OEMs. I do not speak about McLaren or customer like that. Mainstream OEMs trying to manage with zero emission, very lightweight vehicles in carbon for a complete floor and especially in a trunk compartment. And it was a disaster for the radiation efficiency. And basically, I like the story because at the end of the study, the OEM was able to save up to 17 kilograms on the full car. But finally, to recover the final performance and to better manage the high frequency radiation, they have to increase the weight of the insulator, almost 17 kilograms. It was a very good point for us, but the result was absolutely zero for the planet. So there is, for us as porous media engineer, a real added value there to be able to manage that kind of performance. Finally, the second initiative for Faurecia is about cockpit of the future. Cockpit of the future mean for us all the solution to deliver a connected, versatile, and predictive cockpit. Let me focus on material. Again, and sorry about that, but the material is not the main reason why our customers, our end users are buying a car. The end users are today much more interested again in the phone connection or the infotainment management rather than anything else. For a company like us, we are definitely in a world where we have to combine new usage of a car while maintaining good performance in terms of NVH capability. And I guess it's for us, again, porous media engineer, something very interesting. Let me give you an example about the SIA, the Society of French Society of Automotive Engineer. We do not have so many people there, but until last year, we have a specific congress called in Le Mans, which was driven by the Automotive Congress company, focusing only on NVH and comfort on board. The French Society of Automotive Engineers decided to cancel, not really cancel, but to merge this activity in a much more global organization called Comfort. And this is basically the same thing that we are doing today. The new orientation of Faurecia is to be able to deal not only with porous media and classical material-oriented company, which is true for porous, but which is true as well for instrument panel and complete seat, as I told you at the beginning. But we have more and more to combine this strategy to electronic approach and to the final value of the vehicle. So in that domain, Faurecia recently acquired, let's say, 4 key companies in the world of audio management and quiet mobility management. I like that quiet mobility management. So first we buy Coagent, which is a Chinese company involved in the infotainment unit electronic system. Then we bought Parrot Automotive, which is maybe known by some of you for the drones, but which is also known for Bluetooth connection in a car. And finally, recently we buy Clarion, a Japanese company, a large Japanese company, in order to create, let's say, a unique solution for us to combine this electronic with the classical historical Faurecia activities. This slide is just coming from my CEO, and this is the new vision of the Faurecia CEO about the megatrends for the group. The megatrends for the group are about low-speed ADAS, nothing to deal with porous media, sensor and occupant monitoring, basically nothing, IVI, HMI, and sound. The sound will be, and again, this is not my slide, this is a CEO slide. the sound is defined as a key priority for the automotive business tomorrow. Which means if the car will be an autonomous car, I need to be able to listen comfortably the radio or the phone call or whatever, but I need to be able to do that in a quiet environment, and then the material is in the middle of this activity. So let's say, next step for us, porous media engineer, is definitely to go out of the simple and single material orientation, and is definitely to combine our expertise to the new trends of the automotive market in order to propose and to offer a full expertise in sound management, including porous media. So we are between us. Everybody is knowing, of course, Bose, famous audio management company. This is very interesting because Bose is having a huge communication last week during Shanghai Motor Show about the Bose quality combined with the foam performance in a car. You can find that on Le Monde. And there is a full paper on the fact that Bose need to combine the audio capability, the historical audio capability of Bose with the material performance. So I like that a lot because we definitely have to extend our perimeters to be convinced that all that we are developing is part of the global strategy of the car tomorrow. Because yes, if the car tomorrow is an autonomous car, you will be able to work in the car, you will be able to play in the car, maybe do something else that I can't speak in public. But definitely you will need to do that in a quiet mode, and then indeed combining porous media approaches and electronic-based solution is a key. So just to repeat myself, but again, this is the way my CEO, Patrick Koller, is presenting the company today, and this immersive sound experience is part of, again, sorry to insist, is part of the key strategy for a group like Faurecia, which will be tomorrow a 20 billion euro yearly sales group. Just a few words. No, same word, sorry. Those are the three strategic directions for the cockpit. So differentiate in the IVI market. So this is mainly what we are doing with Clarion. Being the global leader in the monitoring system for wellness and safety. This is something very interesting. If we are speaking about a car, personally, I do not believe that the car will be fully autonomous in the next 10 years. But in the next 10 years, we will have a level 3 autonomous car. And level 3 means times to times, you will have to take the driving command again. So, for example, on a high-speed way, your car will be a full autonomous car, and then suddenly you will have to drive. And the driver monitoring is not only about massage, that could be comfortable, but if we are saying that you need to take the control of the car needs to control that you are able to take the control of the car. So you have to be wake up if you are sleeping. We have to check if you are still alive. So the wellness is definitely about that. And the last strategic direction is reconquer the sound. And again, this will be about porous media. So what does that mean for us? We are developing for pure audio sound experience. We are developing a new capability within Faurecia. So you will find on this chart the historical approach. So we discussed a lot about the carpet performances, the headliner performances. You will find again the IP. But we are developing a lot of bricks to play with the car. So we are, for example, working with sound surface technology. So instead of using a loudspeaker, we may have to use any kind of surfaces surfaces in the car to act as a loudspeaker. Again, this is a key approach because as an example, if the car become autonomous car, potentially the seats will go back in the car, and you will not be localized properly for the loudspeaker. So having sound surface could be interesting. We have more and more beamforming approach. We call that directional sound, but this is basically about beamforming approaches in the car, in order to personalize the message of the GPS or driving assistance. And again, who says beamforming, and we have a lot of reflection management to deal with in the cabin to really focus the sound on the driver, for example. We have a lot of bricks for personalized audio, so embedding, for example, loudspeaker in the headrest to offer something new and being able to offer a real unique experience on that. Again, I will give you a Bose example. Having a loudspeaker implementation in a seat is something easy. Bose is able to do that without us. But managing a proper integration with the foam on the seat to manage the real efficiency of the system is again a unique combination between electronic audio system and porous media system. We are using as well exciter on the seat. I will not develop that too much, but if you are in your sound bubble, let's say having a loudspeaker in the headrest, you are able to obtain your own content, for example, having your music through your iPhone in your seat. If so, you can't use anymore the subwoofer in the car, because the subwoofer is the same signal for all the passengers in the car. So if so, we have to offer something new to fill the low frequency range. So we are able to use haptic audio sensors, exciters, in the seat to perceive, without any audio transduction, and to perceive the vibration of the low frequency through the seat. We are working with a Californian company called Subpack on that domain, coming from the gaming. Of course, we have plenty of audio algorithm, but last but not least is about active noise control. The active noise control combined with porous media activity is more and more used in the car industry to extend the porous media activity. All my speech about soft trim was about, let's say, mid and high frequencies. The product we are dealing with are acting from, I don't know, 300 Hertz, 400 Hertz, up to, let's say, 20 kilohertz. Active noise control is able to deal with 50 to 600 Hertz. So it's again a very interesting combination between active and passive material. Let me dream a bit, and maybe I'm more focusing on activity in 10 to 15 years. But we are listening a lot about any kind of extended performance material. It could be about, I dislike the word metamaterial, but any kind of extended performance material with, for example, any kind of electronic management control of the material could be part of this activity. And again, we as Faurecia will be fully equipped to deal with that. As a summary, this is the way Faurecia is now part of the system. So we were working and we are still working on the passive system, and we are worldwide expert on the passive performance. So basically, this curve is the typical engine level, when this curve is the typical level in the cabin. So classical acoustic and soft trim Faurecia products are able to move from this to this, but we are not working at all in this frequency range, let's say above 300, 400 Hertz. So combining active and passive material will allow us to extend this activity, but the market is not there because the quietness mobility is a need. But you, as final and end user, you don't care about that, because what you are taking care is more and more, sorry to insist, but it's more and more about infotainment, connectivity. You want to obtain your own GPS on the car. And this is about any kind of additional audio systems. But of course, as OEM, we have to deal everything in a unique approach, having, let's say, vertical pillars that are emotional audio approaches. Could be surface audio, I develop a bit, directional audio, beamforming, speaker headrest, or seat-based bass, but on the top of quietness mobility, passive, and active noise control domain. That's it for my slides. This is our ambition, and this is the way we will focus the porous media management tomorrow, not as a single activity, but combined with the electronic domain. Thank you very much.